So far, we've differentiated functions like y is equal to x squared, or maybe y is equal to sine of x, e to the x, natural log of x, whatever, right? But y, in this case, is written explicitly in terms of x, right? But what do you do in a scenario when y isn't written explicitly in terms of x? Like maybe x squared plus y squared is equal to 25, this circle, a circle with a radius of 5. Right? You can't easily isolate for y in this scenario. I mean, theoretically, you could. You could write it as 25 minus x squared, but then you would have to deal with the positive root and the negative root, which makes this a pain to deal with. Right? But how do you take the derivative of a function that's not explicitly defined in terms of one variable? Right? That's where implicit differentiation comes in. Implicit differentiation, a technique that allows us to find dy dx in this case when y isn't isolated. Some key ideas here, right? You would differentiate both sides of the equation with respect to x. You would treat y as a function of x, right? That means every time you differentiate a y term, you would multiply by dy dx using the chain rule. And 3, you would then solve for dy dx. All right, let's attempt this with the equation for a circle, right? Let's try and take the derivative of this, right? So the derivative of x squared plus y squared is going to be equal to the derivative of 25, right? Taking the derivative of x squared, we would get 2x, right? And taking the derivative of y squared, we would get 2y times dy dx, right? You can consider y squared as the outer function and y as the inner function, right? Which we are taking the derivative of right here, right? And the derivative of any constant with respect to any variable is always going to be 0, right? Because that constant is not changing with respect to that variable, right? And now we have to isolate for dy dx, right? So we can subtract 2x from both sides, right? So 2y dy dx is going to be equal to negative 2x, right? And if we divide both sides by 2y, we would get dy dx is equal to negative x over y, right? The 2's cancel out here. This derivative here tells us the slope of the tangent line to the circle at any point x comma y, right? The slope of the tangent line to any point x comma y. All right, let's try and take the derivative where x and y are being multiplied by each other, right? So if we were to take the derivative of the left side, x times y is equal to the derivative of 6, right? Derivative of x times y, we would use the product rule for this, right? So x is going to be, derivative of x is just going to be 1, y will just drop down right here, right? Plus x, we're not taking the derivative of x here, times the derivative of y, which is going to be 1 times dy dx, and the derivative of any constant is just going to be 0, right? And now we isolate for dy dx. So x dy dx is going to be equal to negative y. We subtract 1y from both sides, right? And we divide by x to get dy dx is equal to negative y over x. Notice how both examples give us a slope that depends on both x and y, right? That's pretty typical in implicit differentiation. All right, let's take it up a notch, right? And let's take the derivative of x cubed plus y cubed is equal to 9xy, right? So if we take the derivative of both sides, right, you get the drill here, right? X cubed plus y cubed is equal to 3xy, right? Taking the derivative of x cubed, we would get 3x squared, plus the derivative of y cubed, we would get 3y squared dy dx, right? And taking the derivative of this would be a matter of using the product rule, right? And we can factor out the 9, right? So 9 times 1y plus x times 1 dy dx, right? And we can simplify this a little bit more. So 3x squared is equal to 3y squared dy dx is equal to 9y plus 9x dy dx. Now we can bring all the dy dx terms, right, over to one side. So, and we will bring all the other terms over to the other side, right? So 3y squared dy dx minus 9x dy dx is equal to 9y minus 3x squared, right? And now we can factor out that dy dx, right? We're factoring it out, right? And we would be left with 3y squared minus 9x is equal to 9y minus 3x squared. And we divide both sides by this expression here to get that dy dx is equal to 9y minus 3x squared over 3y squared minus 9x.